Air brake systems have been used in heavy commercial vehicles for many years. They use air pressure as the source of energy and convert it into mechanical force to apply the brakes. Air systems are fitted in preference to hydraulic brakes, used mainly in passenger car and light commercial vehicles for a variety of reasons. But first, let's briefly remind ourselves of how hydraulic systems work. In hydraulic systems, the brakes are operated by the action of the brake pedal, forcing fluid through pipes to activate the wheel cylinders and brake mechanisms. For powerful braking, high operating forces are required, which are greater than can be exerted by the driver's foot alone. For this reason, hydraulic systems use power assistance to increase the driver's effort. Power assistance is provided either by a vacuum or hydraulic booster unit, powered by the engine. In contrast, air brakes need no additional power assistance and are therefore classed as a true power braking system. Air systems enable large braking forces to be applied with little effort required by the driver. The high braking forces are created solely by compressed air pressure acting on the pistons in the brake cylinders to apply the brakes. So what are the key advantages of air brake systems? Well, firstly, air brake systems produce high braking forces. And by using air as the operating medium, there's always a plentiful supply, which doesn't deteriorate with age as occurs with hydraulic fluid. Unlike hydraulic systems, air systems will tolerate small leaks without causing brake failure. This is because the air is constantly being topped up by the compressor. Air is also more environmentally friendly than oil-based hydraulic fluid, and for a truck, a vast quantity of fluid would be required to fill the system. Air brake systems are also very compatible with the ABS braking function. A further advantage is that the air pressure generated for the brakes can be used for ancillary equipment, such as air suspension systems and air-suspended seats. For safe operation and to comply with legislation, air brake systems must offer 3 ways of braking the vehicle. These are the foot brake, normally referred to as the service brake, the parking brake, and the emergency brake. Note that some buses have an additional bus stop brake, but we'll look at that later. The service brake, which in itself comprises 2 circuits, is independent of the parking brake circuit. This feature enables the parking brake to act as an emergency brake in the unlikely event of a failure in the service brake. For this reason, the parking brake control lever has a progressive action rather than a 2-position on-off movement. As the lever is moved towards the parking brake on position, the vehicle's brakes are progressively applied, allowing the vehicle to be brought to a gradual stop. To operate, air brake systems require a supply of air pressure. It's produced in what is known as the pressure generation section of the system and forms the power source for the vehicle's entire air circuits. The pressure generation circuit provides a working pressure of around 10 to 12 bars, a means of temporarily storing air pressure, and a method of distributing it to a variety of circuits. Here you can find out which components make up the pressure generation circuit and discover their approximate location on the vehicle. Bear in mind, however, that this will vary according to vehicle type and model. In this course, we're mainly describing the system of a 4x2 Actros with a traditional air brake system and ABS. In broad terms, there are 6 key elements to the pressure generation circuit. A vehicle's air brake system comprises a number of separate circuits, which are all supplied from the multi-circuit protection valve. The first circuit to consider is that of the service brake. It's divided into 2 circuits, one for the front brakes and one for the rear. In operation, the service brake distributes air pressure to the wheel brakes of all axles when the driver depresses the pedal. Its action is progressive, in that the harder the pedal is pressed, the greater the air pressure at the brakes, and the more the vehicle is slowed. The service brake is extremely powerful and is capable of applying massive forces at the wheel brakes with little effort from the driver. Once again, here's a plan view of our 4x2 vehicle, which will help you learn about the components of the service brake circuit. Basically, there are 7 key items involved, represented here by question marks. The next circuit to consider is that of the parking brake. Generally, it applies the brakes of the rear wheels only and, as its name implies, is used to secure the vehicle when stationary. Note, however, that on certain tractor units, the parking brake also works on the front wheels. Remember that the parking brake can also be used as an emergency brake in the unlikely event of a failure with the service brake. The operating lever can have up to 3 positions, depending upon the vehicle's specification: parking brake off, parking brake on, and a test position for use when a trailer is connected. So what are the main components of the parking brake circuit? Let's find out by using the same approach as we did for the service brake system. Once again, the components are represented by question marks. Although the components and their locations are similar across most trucks, they are placed elsewhere out of necessity in some special vehicles. Here, for example, is the layout of components in a fairly typical bus with the engine at the rear. Having established which components make up the pressure generation circuit, let's now consider the tasks they perform. The task of the piston-type compressor is to take in atmospheric air and increase its pressure to a level sufficient to operate the air brake system. It's mechanically driven by the engine, usually by gears. As you might expect, there are various types of compressors, including 1, 2, and 3-cylinder versions, as well as those with air pressure regulation known as APR. APR compressors incorporate a special valve in their cylinder head that opens when the operating pressure is reached. With the valve open, the unit operates with reduced compression, which contributes to reducing fuel consumption. From the compressor, air pressure reaches the combined pressure regulator and dryer unit. The regulator sets the maximum level of pressure in the system, and the dryer removes moisture from the air. It's essential moisture is removed because any water in the pipelines or components could cause corrosion or freeze in winter, leading to a blockage and potential brake failure. An integrated electric heater prevents freezing of the regulator valve at low temperatures. It's important that the dryer cartridge is replaced at the Mercedes-Benz recommended intervals. From the pressure regulator, air reaches the multi-circuit protection valve. It's directly attached to the pressure regulator and air dryer assembly. One of its tasks is to act as a distribution point, directing air to a number of separate circuits. Generally, these supply systems such as service brake, parking brake, trailer, clutch and gear shift circuits, and other auxiliary systems. The multi-circuit protection valve incorporates air pressure limiting valves and overflow valves with limited return. The limiting valves control the maximum pressure in the different air circuits, while the overflow valves protect the vehicle from a total loss of air pressure should a leak in one or more circuits develop. The components of the air brake system are connected by pipes, which in the majority are plastic. This material is chosen for its flexibility, lightness, and non-corrosive qualities. Any pipes which show signs of damage should always be replaced. The task of the storage tanks, connected to the multi-circuit protection valve by pipes, is to provide a reservoir of air for the different circuits. This ensures there's sufficient pressure to operate the brakes a number of times after the engine is switched off. In addition, the tanks act as a damper to reduce sudden fluctuations in pressure as circuits are operated. Damaged tanks, either due to corrosion or from being dented, must always be replaced. To warn of low pressure in the brake circuits, the instrument panel is equipped with either one or two pressure gauges, warning lamps, and a text display, depending upon the model and specification. In this example from an Actros, there's just one pressure gauge, but with two warning lamps. The left-hand lamp warns of low pressure in circuit 1, which supplies the rear brakes. And the right-hand lamp is for circuit 2, which supplies the front brakes. The gauge displays the pressure in the storage tanks of circuit 1 or 2, depending on which is the lowest pressure. In some vehicles, two separate gauges are fitted, one for each circuit. The minimum pressure necessary for safe operation of the vehicle varies according to the model, but generally it's around 10 bar. The switches and sensor that control the lamps and gauges are generally found on the multi-circuit protection valve. Having learnt about the tasks of the pressure generation components, you can now view examples of what they look like on the vehicle. Now you can learn about the tasks of the service brake components. The service brake valve receives air pressure from the multi-circuit protection valve via the air tanks. The service valve contains two valves, one for the front brake circuit and the other for the rear brake circuit. Consequently, when the service brake pedal is pressed, air is directed progressively to both circuits. From the front circuit valve, air pressure reaches the relay valve that's mounted near the front axle. Its task is to reduce the time between pressing the pedal and the front brakes being applied. It operates in a similar way to an electrical relay, in that it uses a small signal to operate a larger current. The connection between the service brake valve and relay valve is by means of a small diameter pipe. This means that when the brake pedal is pressed, only a small volume of air is required to trigger and open the relay valve. It in turn progressively connects the larger diameter main air supply line directly to the front brake cylinders. This design ensures that when the brake pedal is pressed, the relay valve opens almost simultaneously, and in turn the brakes are applied immediately. With the relay valve open, air can reach the front brake cylinders. These incorporate a diaphragm, piston, and spring assembly. The cylinder's task is to convert air pressure into a mechanical force to apply the brakes. Releasing the brake pedal vents the air pressure to atmosphere. The spring forces the piston back and the brakes are released. Leaving the service brake valve for the rear circuit, air reaches the combined load sensing and relay valve, positioned close to the rear axle. The relay valve element of the component reduces the reaction time between pressing the pedal and the rear brakes being applied. The valve's other task, as its name implies, is to regulate the air pressure to the rear brakes depending on the vehicle load. The valve's connected to the axle by a linkage on steel-sprung vehicles or by an air pipe to the rear air bellows in trucks with air suspension. The valve includes an emergency function so that if the linkage becomes disconnected or the air suspension pipe breaks, it adopts a midway position to enable moderate braking of the rear axle. After the load sensing valve, the rear brake circuit terminates at the combination cylinders. Like those of the front brakes, they convert air pressure into mechanical force by means of a diaphragm and piston assembly. In contrast to the front, the rear cylinders are combined with a second diaphragm and spring assembly, hence the name combination cylinders. These additional components play no role in the operation of the service brake and are for the parking brake function only. Although they have no role in the normal operation of the service brake, the electrically operated ABS valves are part of the front and rear brake circuits. They are located in the circuits between the relay valves and brake cylinders. The task of the ABS valves, of which there are 2 per brake, is to prevent the wheels from locking and skidding. Let's look in a slightly simplified way how they work. One ABS valve is normally open, allowing air pressure to reach the brake cylinder uninterrupted. But if the ABS control unit detects, by means of signals from wheel speed sensors, that a vehicle is in danger of locking, the valve is closed to prevent a further build-up of pressure in the brake cylinder. If the wheel is still in danger of locking, then the adjacent ABS valve is opened. This action releases air from the cylinder and the wheel starts to speed up again. The ABS control unit can operate the valves very rapidly. As a result, the brake pressure can be repeatedly increased, maintained or released to prevent the wheels from locking. Having learnt about the tasks of the service brake components, you can now see what they look like on the vehicle. Now let's consider the tasks of the parking brake components, which of course can also be used as an emergency brake. There are several different versions of parking brake valve depending on the vehicle configuration. In general, there are 2 main types. Firstly, there's a 2-position on-off type for use on vehicles not configured for trailers. The second type, illustrated here, includes trailer control and has 3 positions. These are on, off, and a test position for when a trailer is connected. In fact, the parking brake valve contains 2 separate valve assemblies. One is responsible for the parking brake function of the truck brakes, and the other is for testing when a trailer is connected. In operation, the parking brake circuit works in reverse to that of the service brake, in that air pressure must be present at the combination cylinders to keep the brakes off. The task of the parking brake valve is therefore to release or supply air to the combination cylinders, which it does indirectly via the relay valve. The relay valve is positioned in the circuit between the parking brake valve and the combination cylinders. Like other relay valves, its task is to reduce any delay between moving the lever and the brakes operating. It's triggered by a relatively small volume air signal from the parking brake control valve. The relay valve has two positions. With the parking lever set to off, air forces the relay valve piston down and air is supplied to the combination cylinders. Alternatively, moving the lever to on causes the relay valve to release air from the combination cylinders, allowing the brakes to be applied. The combination cylinders are the final element in the parking brake circuit. They incorporate separate components for the service brake and parking brake functions. The parking brake section of the cylinders incorporates pistons and powerful coil springs. With the parking brake lever set to off, air pressure forces the piston back against the spring and the brakes are held off. In contrast, moving the lever to on causes air to be released from the cylinders. This action allows the force of the spring to move the piston in the opposite direction and the parking brake to be applied. Technicians should note that the combination cylinders include a mechanism for releasing the parking brake should the air supply have failed and the vehicle needs to be moved. A bolt on the end of the cylinder is turned until the brakes are released. This procedure must only ever be attempted after the vehicle has been made safe using wheel chocks and a warning note has been placed inside the vehicle. Having looked at the air brake components and their tasks, let's consider the order in which they are laid out in a typical system and learn a little more about them. The source of pressure is the engine-driven compressor. It's connected by a pipe to the combined pressure regulator and air dryer. The regulator maintains the pressure at about 10 to 12 bar, depending on the model. The task of the regeneration tank, which is remotely connected to the regulator, is to purge the dryer cartridge of moisture. In simple terms, it works by emptying its air contents, which has previously been dried, back through the dryer cartridge when the pressure regulator cuts out. The air passing back through the dryer's granules carries the moisture with it and into the atmosphere. Air flows next into the multi-circuit protection valve assembly, which is directly attached to the regulator and dryer unit. The valve distributes air to a number of independent circuits and regulates their pressure. In our truck example, it limits the pressure to 10 bar for the service brake circuits. Also attached to the multi-circuit protection valve are the switches and sensors for the low-pressure warning displays and air pressure gauges. The independent brake lines that leave the multi-circuit protection valve for the service brake and parking brake circuits connect first to the storage tanks. These provide a reservoir of air pressure. From the storage tanks, air pressure reaches the foot-operated valve of the service brake circuit. And from a separate tank, air flows to the hand-operated valve of the parking brake circuit. At the service brake valve, the circuit divides into front and rear circuits. Both of these circuits lead to relay valves, which reduce the reaction time. In this example, the combined load sensing and relay valve for the rear circuit is of the type controlled by pressure from the air suspension system, as opposed to the mechanically operated type fitted to vehicles with steel suspension. Next in line are the ABS valves, which play no part in normal braking. The air pressure's final destination is the front and rear brake cylinders that activate the brakes. In the parking brake circuit, air from the parking brake valve travels to the relay valve. Finally, air is directed to the spring brake element of the combination cylinders that operate the parking brake mechanism. To assist technicians in understanding how the air brake systems are laid out and to which ports the numerous pipes connect, Mercedes-Benz produces pneumatic circuit plans. These are especially helpful during fault diagnosis. Similar to wiring diagrams, each component is identified by a symbol and designation that are identical across all models. Having described the layout of the air brake system and introduced the pneumatic circuit plans, let's see how they help in understanding the operation of circuits, starting with the service brake. Here we're looking only at the service brake circuit. We've condensed the diagram by removing all unnecessary items. Solid red indicates supply pressure. Dotted red denotes control pressure. Solid yellow indicates brake pressure. Dotted yellow denotes control brake pressure. Solid blue is for air spring bellows pressure. Dotted blue denotes air springs control pressure. And finally, black lines indicate electrical cables. Of course, only some of these colors are used in the service brake section of the plan. As you know, the components are identified by symbols and designations. In addition, these references on the lines indicate to which component and section of the plan they join. For simplicity, we're removing these in the following diagrams. So let's start our explanation of the service brake at the valve and follow just the rear brake section first. We'll partially animate the circuit in stages to help explain how the plan assists in understanding the circuit. Air is supplied to the service valve by two independent lines and to the combined rear relay and load-regulating valve. The plan clearly shows that internally the service valve contains two valves, one for the front circuit and the other for the rear. The brake light switch, which is connected to the pedal, is also symbolized here. Pressing the brake pedal opens the two valves. Air from port 2-1, which is for the rear circuit, travels to port 4 of the combined relay and load sensing valve. This activates the valve and connects air pressure from the supply at port 1 with port 2. Air is thus directed via the ABS valves to the rear combination cylinders at port 1-1. In response, the service brake pistons are pressurized and the brakes are applied. The level of air pressure acting on the pistons is regulated by the load sensing valve according to axle load. And of course, if a wheel is in danger of locking, then the ABS valves for that particular brake are activated to maintain, reduce, or increase the air pressure acting on the cylinder. The valve for the front brake circuit is activated by air pressure from the upper valve. This action directs air pressure from port 2-2 of the service valve to the relay valve. Note that if for any reason the lower valve isn't operated by the action of the air pressure, then a mechanical connection between the two valves is made. In response to the air pressure from port 2-2 of the service valve, the relay valve opens and connects port 1 with port 2. Air pressure from the storage tanks, that's waiting at port 1, then flows instantly to the front brake cylinders via the ABS valves. As a result, the front brakes are applied. The parking brake circuit is illustrated in a similar way to the service brake. The plan shows the parking brake valve is supplied with air at port 1-1, and air is also supplied to the relay valve at port 1. Internally, the parking brake valve assembly has two separate valves, one for the parking brake operation, and the other is for testing the holding power of the truck brakes when a trailer is attached. With the park brake lever set to off, air pressure passes through the valve, exiting at port 2-1 and acts on the relay valve via port 4. The air pressure holds the relay valve in the position it's illustrated, which means there's a connection between port 1 and port 2. Air pressure can therefore act on the spring chamber side of the combination cylinders, and this keeps the brakes off. So what happens when the parking brake is applied? Well, moving the lever to on, that's 1 on the plan, pushes the top valve down. This vents the relay valve's control line to atmosphere via port 3. The drop in pressure deactivates the relay valve and releases air pressure from the combination cylinders to atmosphere via port 3 of the relay valve. As a result, the force of the springs applies the parking brake. Note that with the parking lever in position 1, the lower valve, which is for testing the holding power of the parking brake when a trailer is connected, does not move. This valve only operates when the lever is moved into position 2. With the parking brake lever on, the lower valve for the trailer brake function is in its rest position. In this condition, port 2-2 and the line to the trailer control valve are vented to atmosphere via port 3. However, when the brake lever is moved to the trailer brake test position, by pushing the handle in and moving it fully down, the lower valve is activated. This directs air pressure from port 1-1 to port 2-2 of the valve assembly, and as a result, the separate trailer brake control valve is supplied with air. Because the trailer control valve functions by inverting the signal, supplying it with air actually releases air from the trailer brake cylinders. And on a trailer, reducing the air pressure releases the brakes. This test position enables the driver to check the vehicle is parked securely, even if the air pressure to the trailer brakes should fall or fail. Throughout this program, we've described a traditional air brake system as fitted to a basic vehicle. However, depending upon the model and specification, additional systems or components are often fitted as well. With multi-axle vehicles, for example, supplementary relay valves and brake cylinders are necessary. And with some models, an air-operated engine brake may be fitted, which partially restricts the exhaust pipe by means of a flap to improve engine braking. Other options include air suspension. As you might expect, vehicles equipped with air suspension have a lot more components, including suspension bellows, supplementary storage tanks, level sensors, and so on. There are also component and system variations due to different countries' legislation. In the UK, for example, the front brakes of tractor units have combination cylinders incorporating springs in addition to the pneumatically operated piston. To accompany these systems are dedicated pneumatic plans, showing the layout of the systems and their components. Always refer to these before working on the vehicle. One example of an auxiliary system fitted for a specific purpose is the bus stop holding brake of buses that stop frequently. It's controlled by a switch on the instrument panel or automatically when the doors are opened. When operated, a reduced air pressure of 3.5 bar is applied to the rear axle service brake diaphragms. This pressure is sufficient to prevent the vehicle from moving while pausing at bus stops. The benefits of the system are reduced compressed air demand, quicker operation because the service brake cylinders release the brakes faster than the spring-operated parking brake mechanism, and reduced effort for the driver. However, the bus stop brake should never be used when parking. The driver must always engage the parking brake before leaving the vehicle. Here's a pneumatic plan of the circuit. Note that the symbols in circuit plans of buses are slightly different to those used for trucks. Now let's see how the circuit functions. Air pressure from the multi-circuit protection valve is supplied to the brake pressure limiting valve, air storage tank and rear axle relay valve. The pressure limiting valve restricts the pressure to 3.5 bar and directs air to the electrically operated bus stop valve. When the driver's switch is operated and in turn the solenoid valve opens, pressure is directed via the breather valve to the two-way ball valve, which also opens. This enables air to travel via the ASR valve and load sensing valve to the rear axle relay valve, which partially opens in response to the reduced pressure of 3.5 bar. This action directs air from the storage tank and multi-circuit protection valve to the service brake diaphragms of the rear combination cylinders, and the brakes are applied. The pressure acting on the diaphragms is limited to 3.5 bar by the movement of the relay valve, which opens in proportion to the control line pressure. When the bus stop brake is switched off, air from the brake cylinders is quickly vented to atmosphere via the breather valve, and the brakes are released rapidly. You hardly need reminding that a vehicle's braking system is critical to its safe operation. Irrespective of the type of vehicle, the brakes must be in good working order before it's driven. It's therefore essential that a vehicle is never driven if the stop light is lit or there is insufficient air pressure, irrespective of how short the distance. Furthermore, because of the serious repercussions of incorrect repairs, only qualified personnel should ever work on an air brake system. And remember, due to the high pressures which could easily cause injury, always refer to the latest safety information found in WIS or the service net before starting any disassembly work.